Howdy folks. In this pre-work we want to look at rational exponents. So I'll define what those are and we'll start working with them. I want to point out that this pre-work builds off of the two earlier pre-works that we've done on exponents. One that covered the basic properties, and you can access that here, and one that covered the nth roots here. So if you haven't done those pre-works, I do recommend stepping back and working those first. Or even if you feel rusty with the content, if there's something I'm doing in here that's not making any sense at all, you may want to jump back to these two earlier pre-works to review or to go through for the first time. So I want to define what we mean by a rational exponent here. So a rational exponent could be written in the form a to the, and I'd like to use some color coding here, so I'll put m divided by n. Color coding that. So we have two ways to interpret this. We can interpret this as either the nth root of a, oops, that's supposed to be a different color, folks. The nth root of a raised to the m power, or we can define it as the nth root of a to the m. In both these cases, we assume that all of the roots are defined. Okay. What I'd like to point out here, folks, is I color-coded this for a reason. And so if I were to just do an expression like a to the m over n, I want to point out that the denominator is equal to the index of the root. So here in the rational exponent, the denominator of that power is n. That becomes the index of our root. And the numerator is the power that we raise the expression to. So the numerator is the integer exponent. Or integer power. So let's put that into practice here, folks. And I'll color code these first couple to help with this. So if we were to do 8 to the 2/3 power, we have two choices for how we want to rewrite this. I could rewrite this as the nth root of 8 squared, and then take the cube root of that answer. That's one way I could do it. I generally think that the other way is a little bit more user-friendly, where I'm going to take first the cube root of 8, color coding this, and then raise that result to the second power. But I want to point out, no matter how I choose to rewrite it, the denominator became the index of the radical, and the numerator is the power over the base, that integer power. So simplifying off of this second expression here, and skipping the color coding now, if I want to take the cube root of 8, the cube root of 8 is 2, and then if I square, that's that 2 here, squaring, that would give me an answer of 4. So let's do the same thing down here. If I were to take negative 8 to the 2/3 power, this is the same thing as a couple different ways I could write it, but I'll rewrite it as the cube root of negative 8 quantity squared. Now, in this case, with a and b, we get the same answer. I don't think that will always happen, so I want you to be careful with that. But here, if I were to take the cube root of negative 8, the cube root of negative 8 is negative 2, and if I square negative 2, I get positive 4. What I want to highlight next is this expression here where we said provided all roots are defined. I can write this expression if I wish, but it turns out that this expression actually isn't defined, and that might be a little bit hard to see when I write it as a rational exponent. But as soon as I try to rewrite this as a expression involving radicals, we see that this is the same thing as, say, the square root of negative 8 cubed, and there is no real solution to this. No real number. Okay, or not a real number. The solution to this is not a real number. Okay? Put another way, this is not defined. In fact, that's how I'd like to write it. This is not defined in the reals. Okay. Let's take a look at this expression here. What we end up in this case is, although we'll be able to simplify it, we will still have radicals in the problem. So here we're being asked to evaluate 8 to the 3/2 power, and I can write this a couple of different ways. For instance, I could write it as 8 cubed and then take the square root, but 8 cubed is a very large number. It's easier for me to do it the other way, so I'm going to go ahead and take the square root of 8 and then cube it. And there's a few ways we could work this, but if I were to take the square root of 8, that's the same thing as 2 square root of 2 quantity cubed, where I went ahead and simplified this radical using radical simplification techniques. Then I could go ahead and write this as 2 cubed, and then the cube root of 2 cubed, bringing this power of 3 inside here. So I distribute the power of 3 to both terms in the product, and then I brought this power of 3 inside that radical. And so that would give me 8 times the square root of 8, and further simplifying this gives me 8 times 2 square root of 2, or 16 square root of 2 for that solution. That was a little tricky, folks. So I just want to point out that we first rewrote it one of two different ways, and then I went ahead and simplified this radical. There's other ways I could have done this, but that made the most sense at the time. So I wrote this as 2 radical 2 raised to the 3rd power. Then because of my properties of exponents, if I have a times b to the 3rd power, that's the same thing as a cubed b cubed, and that's what I did going from this line to this line here. So look through that. Let me know if you have any questions. I do agree that it is a little tricky. Okay, the next thing we have is the fifth root of negative 32, or let's say it another way, negative 32 to the 1/5 power. So if I rewrote that, that's negative 32. Take the 5th root of that. The 5th root of negative 32 is negative 2. Why? Because if I took negative 2 to the 5th power, we'd end up with 32. So there's my answer to that problem. So here I have just a generic rational exponent, and I just wanted you to practice rewriting it one of two different ways. One way you could write it is to say that it is x to the 8th power, and then we'll take the bth root of that. Or you could say that that is the bth root of a raised to the, the bth root of x. That should be an x in that radicand position, folks. The bth root of x raised to the a power. Either of these solutions is fine, and you should be comfortable giving either one. So what I'd like you to do is, on your own, I want you to go ahead and work through this expression here, or these 6 problems here. Give it a shot. I do give a key to one of them, but I do leave you to work the remainder on your own. And then what I'd like you to do is, just for practice, I want you to recopy your properties of exponents, which you may have a QR code for, or you can access the hyperlink. Then I'll see you in the next video. Thanks, folks.